Hello, students, and welcome to math class today. We're going to do some exponent work again today, a little bit of review of what we've been doing. But first, when we work on our do now, we will set a personal accomplishment goal. We're going to finish up our work with exponents before we start square rooting, and we're going to complete a review. And our essential question will ask, how do I evaluate exponents? And how can I rewrite those negative exponents so that they are positive? After we watch the video, we will complete, or as we watch it, complete 20 problems. And I want to challenge yourself to memorize the rules that you're learning about exponents. We're going to complete a sentence. When a value has an exponent, that means that value is what? We'll write that. And when I see a negative exponent, I should rewrite it as a positive exponent by doing what? And I bet a lot of you already remember this from last week. Make sure to show me your work to get full credit. If you can't show it on camera, then take a picture and send it to my email, which is right down here. Remember, we don't have homework unless you don't finish your work. That doesn't mean you don't have to work during class. You do have to work during class. But whatever you don't get done, just go ahead and try to finish it up for homework. But you must show me your work. So even if you haven't finished it at the end of class, I want to see what you've done during class. That's your class participation. We're going to keep our cameras on for our discussion. And at the end, when we show our work, respond when you're called, whether it's at the beginning, middle, or end of the period, and then show your work as I've said. We are having full classes on Wednesday, okay? So make sure you log into your classes on Wednesday. Spirit days are here, and tomorrow is team and university day. So if you have a university or a sports team that you support, then please you can go ahead and wear those colors. And here is the flyer about our spirit days that are coming up. This is tomorrow. Then we've got Friday, January 15th, and Tuesday, January 19th, and Friday, January 22nd, which we finish up with Superhero Day. So our New Year's resolution, what is a personal accomplishment goal that you can make for 2021? Okay, I have a fitness goal and I have a professional goal that I'm going to do. I'd like you to write yours right here. When we discuss this in class, if you're up to sharing it with the group, that would be great. And we will get back to our exit ticket after we do our work. So today we're finishing up with exponents. We'll complete a chart and we'll do some evaluations. So if I have this, like I have in number 1, 5 times 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 5, that is repeated multiplication. That's why it's an exponent, and we can express that as 5 to the 8th power. If we were to use a calculator and keep evaluating that, we'd have a very large number of 390,625. Remember, it's 5 times 5, which is 25, times 5, which is 125. And if you keep going, these numbers get big rather quickly. So 9 times 9 times 9 times 9 is 9 to the 4th power, or 6,561. Negative 16 times negative 16 as an exponent, we would show it to be negative 16 in parentheses squared with an exponent of 2. But when you multiply a negative times a negative, you have a positive, in this case, 256. Now, the fractions will work the same way. 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2 is 1/2 to the 1, 2, 3, 4, 5, 6th power. But if we keep multiplying those denominators, we will end up with 1 over 64. This is a rule you'll work more with when you get to algebra next year. We have -1 times -1 times -1. Keep the -1 in parentheses and put an exponent outside the parentheses. But you've learned a negative times a negative is a positive. So -1 times -1 is +1. But then +1 times -1 brings it back to negative again for -1. In this next problem, number 6, we want to keep the -2's and the 3's separate, and we'll start with the smaller quantity. So we're multiplying -2 times -2 times -2 for -2 to the third power. And that is being multiplied by 3 times 3 times 3 times 3 times 3, or 3 to the fifth power. Now remember, we can reorder these because multiplication, like division, is commutative. Order does not matter. So if we multiply -2 to the third power, which is -8, times 3 to the fifth power, which will give us -8 times 3 to the fifth power, is -1,944. And a calculator will help you with that. Similarly, number 7, we have 3/4 to the 1, 2, third power. So 3/4 in parentheses to the third power times 8. 8 times 8 is 8 squared, or 8 to the second power. And when we evaluate 3/4 times 3/4 times 3/4 and multiply that times 8, which is 64, the 3/4 is going to reduce the 64 because it's less than 1. So the final answer will be 27. Now, we don't have any numbers here, so these are kind of easy. We can't really find the value of number 8 because it's a variable. But we can call that n to the 1, 2, 3, 4, 5, 6, 7th power. Now, number 9, we have letters and we have numerical values. So we have that -4 times -4 times -4 times -4. That is not -4 times 4. -4 times 4 would be repeated addition. This is -4 times -4, let me write that down, times -4 times -4 times -4, or -4 to the fourth power. That's being multiplied by xy, which is repeated 3 times. So we have xy in parentheses to the third power. So -4 to the fourth power times xy to the third power. Now we can evaluate the -4 to the fourth power. This quantity here, let's change my color so I can show it to you. This -4 times -4 times -4 times -4 equals 256. But we cannot evaluate xy to the third power, so that will stay in parentheses with a power of 3. And finally, number 10, we have x minus 7y. It's a quantity, it's in parentheses, and it's multiplied by itself 1, 2, 3, 4 times, which would be x minus 7y, parentheses, to the fourth power, and we are not able to find a value for that unless we were to substitute x and y for a value. So now we've got expressions. Some of them have negative exponents. We're going to rewrite them with positive exponents, and if we can, we will simplify. So remember, to write an exponent as positive, we put it under a denominator of 1, and that way we don't have to have the negative in the exponent. So 1 over 7 squared is 1 over 7 times 7, which equals 1 over 49. 10 to the negative third is 1 over 10 to the third, which equals 1 over 10 times 10 times 10, which equals 1 over 1,000. Number 13. Try 13 and 14 yourself and see what you can do. Then come back. Okay, here we go. 1 over 4 to the fifth, which is 1 over 4 times 4 times 4 times 4, which equals 1 over 1,024. You might need a calculator to help you. Number 14, 3 to the negative seventh times 2 to the negative fourth is 1 over 3 to the seventh times 1 over 2 to the fourth. And let's rewrite that. 3 times 3 times 3 times 3 times 3 times 3 times 3. 3 to the seventh power is, we'll put 1 in the numerator, and the denominator is 2,187. And 2 to the fourth is 2 times 2 times 2 times 2, or 16. And if we multiply those together, we have 1 over 34,992. And you would definitely need a calculator to compute that. Number 15, 6 to the second times 12 to the negative 2 power. So 6 to the second times 1 over 12 to the second power. Well, 6 to the second is 36. Remember, we can put any number over 1. Times 1 over 12 times 12 is 144, which will give us 36 over 144. And that simplifies to 1/4. 36 goes into 144 4 times. This would be a 1, this would be a 4. So do you remember your zero exponent rule for number 16? Anything raised to the 0 power equals 1. So 2 to the 0 equals 1 times 15 to the third power times 9 to the negative fourth, which we will rewrite as 1 over 9 to the fourth. And 1 times 15 to the third, well, 15 to the third is 3,375. And that times 1 is 3,375. We can just put that over 1 so we can show our multiplication of fractions. 9 to the fourth is 9 times 9 times 9 times 9, or 6,561. So that would give us 3,375 divided by 6,561. If we used a calculator to help us, we could reduce that to 125 over 243. And let's do numbers 17 and 18, 19 and 20. Try them on your own first, and then come back. So y to the negative eighth, all we can do is put that under a denominator of 1 to get rid of that negative exponent. 18 is very similar to number 17. We just have two variables being multiplied by each other. 1 over a to the third times 1 over b to the fifth. And we can simplify that to 1 over a to the third, b to the fifth. Number 19, we'll simplify r to the negative eighth as 1 over r to the eighth times 1 over s to the sixth times t to the 0, anything, even a variable, raised to the 0 power equals 1. So what this simplifies to, anything times 1 is itself. So this simply simplifies to a 1 in the numerator and r to the 8th power s to the 6th power. Let's rewrite that so it's a little clearer. R to the 8th power s to the 6th power. And that's a final answer. And finally, for our last problem, for the negative 2 power, c third, d to the negative 1. So we rewrite that now remember, d to the negative first power is not d to the first power. We have to be very mindful of that. So we have 1 over 4 to the second power times c to the third power times 1 over d to the first power, or we can just say d. We don't have to put the 1 when it's 1 power. Now, one thing we can do when we think of this is put a denominator of 1 under the c to the third. I think that'll help you understand the simplification here. So 1 times c to the third times 1 equals c to the third. That's our numerator. And our denominator is 4 to the second times d to the first power, or simply d, but we're still not simplified yet. We can evaluate 4 to the second, which is 4 times 4. So we will have c to the third in the numerator, 4 times 4, which is 16, and then our d, and that's our final answer. So let's go back to our exit ticket. When a value has an exponent, that means the value is repeatedly multiplied by itself. So 4 to the third power is 4 times 4 times 4. So 4 times 4 is 16. 16 times 4 is 64. A to the third power equals A times A times A, and we cannot simplify that any further. Now, when I see a negative exponent, I should rewrite it as a positive exponent by placing it under a numerator of 1 So if I have 6 to the negative 2, I would rewrite that as 1 over 6 to the second. If I have a to the negative 3, I would rewrite that as 1 over a to the third. So keep practicing, go back over them a few times. Don't forget to wear your team or university, favorite team or favorite university colors for tomorrow. Keep practicing, keep working hard. Most important, show me your work. I have to see your work to give you credit for it, okay? I love you, but I'm not a mind reader, so I need to see your work. Keep practicing. Congratulations on working so hard. And remember, with practice, you'll be great.